Assalamualaikum and good afternoon or good day to our lecturer and our fellow friends. So my name is Muhammad Usman, with my tag number 8063, and today I will start the presentation of our group for the class of ITL, Internet Working Laboratory Technology, and this is our group project. Okay, so for the introduction, internet connection nowadays is a crucial for business, commercial and businesses purposes. Because of this, a reliable network must be established, and then the knowledge to design a proper and stable network is very essential because it can save a lot of time and a lot of money, and you can also do it efficiently if done right. Based on the slides that we have provided, this is proof that 96.8% of the population in Malaysia in 2021 uses internet on some level, whether it be commercial or businesses. But it can be said that almost all of Malaysia uses internet nowadays. So there needs to be some kind of network design for every place they go, and whether it be at home or at a business place or a restaurant or something like that. Okay, and also for mostly for business purposes, COVID-19 had a major impact on how to say digitalization of the businesses, which leads them to use more network or internet to expand or to keep the business alive. Okay? So a network design is very essential. Okay, so for the scopes and objectives, for a small network, the scope is connectivity, high internet speed, smart home integration, media and entertainment, security and privacy. That's it. That's the gist of it, the basic or general rule of it. Meanwhile, for media network, it is some of them are same. There's like connectivity or connection to the internet, high bandwidth internet access, not just high speed but high bandwidth, to allow more users or more devices to connect at one time, at one single time. Security and privacy, and then authorized access. What this means is that because media network in our situation or in our project, it is for only for students to use in their student lab, computer lab. So let's say you are a visitor to the university, you're not allowed to use the network in order to efficiently use resources only for the students or for the staff, not for outsiders. Okay. And the objectives for small network is reliability, accessibility, future-proof performance, and security. What I want to touch here is future-proof because when people design or want a network connection in their home, they don't just tend to use it for a year or so. They tend to use it for as long as they could, as long as the system or the hardware could support it. Okay, so this is why future proof is important because uh, this network tends to cost a lot of money for some people, me included. So you have to the objective is to make it last longer so that people can enjoy it before upgrading, before it is even worth upgrading. Okay, so for the objectives of the media network is reliability, accessibility, future-proof, performance, and security. Kind of the same because it's the same can be said about future-proof. What I want to touch here is security because how to say media network tends to have a lot of users and can really see or like prevent something malicious going on, but we can try our best to prevent unauthorized access so that those who do access the internet, we can see what they do, like maybe they do something inappropriate using the network. Okay, thank you. Okay, so for the internet users and specific needs, for small network, the internet users is domestic or commercial users like me. What this means is daily life users, just to browse social media or watch movies, play video games, nothing heavy such as running simulations, running virtual machines up in maybe 2 to 3 locations far away, doing what is my data mining or something like that. You can, but it's not intended use lah. There will be hiccups here and there. So and then for the media network, the users is scientific and educational users. What this means is that while it is mainly for research and how to say demonstration of various things you can do, such as a computer lab in our faculty, you can run virtual machines on all of the computers and connect them with one another, and also streams presentation here and there, especially during COVID, and that is the use lah. And then the specific needs for a small network is parental control with the Wi-Fi extender. This is in demand of the question of the requirements earlier. It's also in the report to control access of any younger users or younger audiences which will use the internet, whether you like it or not, because kids nowadays tend to use the internet a lot. So we have to put a filter or something to block them from seeing contents that they're not ready to accept, or because they don't know what's wrong or right, so then they don't really know whether it's good or bad for them in the long run. Okay. And then for the media network, the specific needs are high bandwidth router, physical firewall, Wi-Fi access point, and switch. High bandwidth router means is not the commercial use, but more like industrial use, the ones with many ports or many have many access to devices to allow it to connect to. And then physical firewall is I can explain it, but it just looks the same as router, but instead it has a computer in there, a microchip in there. The purpose is exactly to filter or to just be a firewall instead of a software. Now you have a dedicated hardware integrated with the software as well, so it's easy to configure and it's easier to implement. Also, it's more steadier and more reliable. Then Wi-Fi access point is for the wireless devices such as our phones, and then tablets, tablets to connect to, because students nowadays tends to bring not just one, maybe for me example I have one phone and one tablet, just to go to class, not to mention my laptop which I use to record this video, and then a switch is to connect to many more devices, yeah, but wired lah, for all of the computers in the lab. And then the shared specific needs is ISP contract, modem, firewall, network interface, and Ethernet cables. This is like basic stuff. In order for you to have internet in the first place, you have to make a contract with the ISP, the internet service provider, maybe Setcom or Maxis or any brand lah that they choose to be useful. And then modem, I think the basic modem is to modulate the signals into usable for devices. Firewall, as mentioned earlier, network interface is like I think the network interface is already embedded in our devices, but in the computers you usually have network NIC and network interface card. And the Ethernet cables is just to connect all the physical computers to one another using the switch. Okay, so this is the small network design assumption. This is for the small network I mentioned earlier. So this is just a simple, more like earlier planning. And what we decided to do was there's the essential is there, a firewall, a modem, and a router, and like another thing, but the main thing here is wireless access point. In order to allow wireless devices to connect to it, because in a small network such as in a home network lah, basically that's what it's typically used for. A home network usually consists of many wireless devices, because nowadays everyone has smartphones, can even our laptops are wireless. The only even smart home devices are wireless, as we did here, like smart home devices, maybe a smart TV or something like that. The only thing, but a wired connection is still there, such as a PC, a computer. That's why we have one here PC, and then maybe something else such as telephones, but that doesn't really use internet. That just use the phone line. Okay, that's it for the small network design assumption. Okay, so we're back with a medium network design assumption. This is for the computer lab that is requested. And then what we can see here, the basic is there, from the network, from the internet, to the firewall, to the modem, and to the router as usual. But this time, there is an additional devices used, which is a switch. And the switch is to allow multiple internet cables to be connected to it, and then the cables can go through what we assumption, assume is servers, printer, and multiple computers because it's stated in the question. There are 30 computers, if I'm not mistaken, and then network printers to print stuff lah. And then also file servers or is it data servers, if I'm not mistaken. Okay, and then also AI as usual, wireless access point because this is standard nowadays. We have to have Wi-Fi in order to connect our phones, as I mentioned earlier. And then wireless access point, what we assume, what we wanted to be is secure, requires authorization so that only students or staffs can use it. Okay, that's it for the medium network design assumption. Okay, moving on to the types of data and sources. For the small network, the data types is text, video, image, sound, and signal. Text. I think the first four is I think basic. I think we all know text is like when you text people, emails and like that. Video is when you send a video. Some nowadays or I think every day people send video to one another. Image is just a still image, and sound maybe voice note, something like that. But for the signal is for the smart home appliances. So in order for smart home appliances to work seamlessly between one another, for example, like a smart light bulb or smart door lock, it has to send signal towards something, mainly towards our phone. Because, for example, if you want to close the light or the bulb, can we just use our phone? Then it sends a signal, turns it off. Okay. Then for the media network, data types is text, video, image, and sound. We didn't include signal in this because there was no apparent evidence or need for smart home appliances. Even though there are, even if there are, uh, daily users will not be able to send signals. Because imagine if 30 students would be able to turn off the lights using their phones, so it would be hectic. And then so it's not available publicly lah, but I don't think so. Okay. For the sources of small network, data sources is smartphones, laptops, tablets, desktops, smart TV. This is the signals. Smart home and smart home appliances, and then this is for the signals lah. For the previous one, smartphones, laptops is just all of the above: text, video, image, and sound. Okay, and then for the medium network, smartphones, laptops, tablets, the same. The smartphones, laptops, tablets, desktops, printers, and servers. Okay, with the added printers and servers lah. Okay, thank you. Okay, moving on to the number of users and devices. This is just similar, similar to previous, but I explain. Number of users is 5 to 10 users messages in a small network. This is just a wild guess because from the question we got is how many is it? 3 users. So we just assume each person has 3 or 2 devices. Just multiply it, so you get this 5 users. And then for the medium users is 30 to 50 users. Again, this is just a wild guess. Not wild guess lah. Statistically educated guess. I can say like that because from 30 PC, we assume that 30 students, including the lecturers, are the 31. So maybe times 2, something 60 or above like that. And the number of devices is 10 to 20 devices. This is mentioned earlier for the small network, and also for the medium network, it is 60 to 80 devices. Okay. What the number of devices is actually varies, but it's safe to say that each person has 3 devices nowadays: phones, laptops, and tablets. So that's why we just add times 3 times 2 to be keep it safe also. Thank you. Okay, moving on to the next part, which is transmission speeds and potential loads. For the transmission speeds, for the download speed for a small network is 90 to 100 megabit per second. This is wired, and then 25 to 40 megabits per second for wireless. This is just according to the advertisement or marketed by the ISP. This is just the highest the network can reach, like the fastest. It doesn't actually peak at this speed all the time. The most you can get is, to be honest, to be brutally honest, maybe you just get 50 megabit per second. I'm not saying it's bad, but maybe it's depends on the time of day because high traffic. Okay, and then for the medium network, it's 150 to 200 Mbps megabit per second for wired, and 50 to 70 megabit per second for wireless. Okay, and this is just like the advertisement or marketed by the ISP, but you can see where I'm going with this, especially in a high traffic, high with a high number of users, that we will not reach this speed in daily life or in real time in real use. Okay? So for the upload speed, however, for the small network, it is 20 to 30 megabit per second for wired and 10 to 20 megabit per second for wireless. I think this is pretty standard, even though ISP or internet service provider doesn't actually provide this information. But you can see using speedtest.ookla or something like that. I think upload speed is very important also because we send videos, so we just don't receive them, we also send them towards other people. Okay, and then for the medium network is 20 to 50 megabit per second for wired connection and 15 to 20 megabit per second for wireless. Quite similar, but I think what's important is download speed. Okay, thank you. Okay, so the next part is storage needs. For the small network, the storage needs is external hard drive. This is cheap and it has lots of storage. That's the reason. External hard drive can be many sizes nowadays. I have the traditional one like the SL, the cube one, also just like in a pen drive. Pen drives can come up to 1 terabytes nowadays. Can also be used as external hard drive. And then it's just used for backup, for emergency or private data you don't want it lying around. And for the media network, this is the function of the servers we have earlier, or according to the question, file servers. It is able to provide access to data all the time when needed. For example, one that we learned during our data server room visit is that the servers actually hold data like projects for the lecturers or I think for mostly lecturers or master students, I think, so that they can access it anytime they want without having to store it in the devices, because I think it can take up a lot of space. Okay, moving on to the next part. Alright, so continuing where we left off, now we're going to talk about our small network design, or at least this is one that we designed. As we can see here, they are a bit similar to the design assumption. We have modem, okay, and then router connected to it. And then from the router, we have wireless access point. This is maybe we can use extender. No. Wireless access point is just the access point lah for wireless devices to connect to. And then what we assume is it like two-story house or something like that. We use a Wi-Fi extender to connect to more wireless devices such as the tablet or laptop, as we did in our design lah, as you can see. And then the PC is connected directly to it via wired, using wired connection. Because usually that's how PC connects. I mean, there are PCs that can use wireless, but we just assume it uses a wired connection. Okay, and then for the smart home appliances, it connects directly to the router or via wireless signal. Actually, the reason why we don't put it in the it connects to the wireless access point is because it's a lot easier for it to connect to the straight to the router, because a wireless access point is, how to say, you have to set up another authorization for the devices. Okay. Okay, so continuing to the medium network design, what we plan is this setup lah. It's just similar to the small network in terms of basic connection first, except this time there is a firewall in between the modem and the outside internet, the connection outside lah. This is the physical firewall that I mentioned earlier. Okay, it's placed before the modem. Okay, and then after is the router, like as usual. This time the file servers, the two servers, are connected directly to the router to allow greater speed for them lah. And then there are one wireless, I think it's maybe more, but this is a design. So the wireless access points will be for the laptop, smartphones, and wireless printer, uh, and devices of the students and staffs, which are wireless. Okay, and then from the router, there should be a switch. This switch is the main connector for all of the desktops, the 30 computers in the lab itself. Okay, this time we use 3 switches connected to one switch, which is connected to the router, or maybe just one switch. This is just a design. I think that's it from my part. Thank you.
Assalamualaikum to Dr. Johari. My name is Sadatunisha binti Rahim and I'm going to present on equipment and cabling chosen for small home network and medium network for university lab. For the cabling, the suitable cable for small home network is Cat6 UTP 24 AWG. AWG here stands for American Wired Gauge, where why I said this cable is suitable for small home network because the cable performance is better in shorter distance and which support gigabit Ethernet speed. This cable also capable to handle higher bandwidth and faster data transmission rates. Data transmissions uh, in our daily tasks, for example, like file transfers or video streamings. Next, UTP is susceptible to electromagnetic interference, and the twisted pairs in these cables helps to mitigate interference, essential to avoid running the cables alongside sources of interference. The sources of interference, for example, like fluorescent lights. Next, for the router, we are using Archer AX53 AX3000 dual band gigabit Wi-Fi 6 router. Wi-Fi 6 advantages is to improve speeds, better performance in congested network traffic, increased capacity for multiple devices compared to the previous Wi-Fi standards. Wi-Fi 6 also suitable for smart home environments, and this router also offers dual band functionality, which is 2.4 GHz bands and 5 GHz bands. 2.4 GHz bands is better coverage, but it is prone to interference, while 5 GHz bands deliver faster speeds with less interference, but only in shorter distance. AX300 speeds refer to the maximum combination of speed across of both bands. For the firewalls, we are using software firewalls, which is already installed in the router, SPI firewalls. Why we are using software firewalls? Because it is cost effective than hardware firewalls, and it is already installed in the router, so the installation is easy. Other than that, this router also provides parental control, which is home shield parental controls, which the features provided is custom profiles, professional content filter library, family time, bedtime, off time, time rewards, family online time ranking, pause the internet, weekly and monthly report. Next, for the modem, we are choosing Archer VR 400 AC 1200 wireless MU MIMO VDSL ADSL modem. MU MIMO here stands for multiple user, multiple input, and multiple output. This modem offers speedy Wi-Fi, which is experienced in wireless connections with 867 Mbps, which is 5 gigahertz, plus 300 Mbps, which is 2.4 gigahertz dual band Wi-Fi. It is also offers a superior range, which two fixed omnidirectional antennas with beamforming technology provide stable wireless and connections and optimal coverage. MU-MIMO technologies here uh, refers to the simultaneously transfer data to multiple devices and also reducing the wait times. Next, for our repeater, we are using D-Link 300 Mbps repeater Wi-Fi wireless booster DAP 1320. This repeater is a portable plug-in wireless extender, and the speed of this repeater is up until 300 Mbps. This repeater offer a and easy to set up the repeater. It is easy to use because the extender is portable and we can plug in anywhere we want to extend the wireless network. Next, for the medium university lab network, the cable that we are using is category 6 STP cables. This cables is useful for university lab to protect interference from electronic equipment that may affect devices. Additional shielding around each pair of twisted wires provide protection against electromagnetic interference and radio frequency interference. This cables also offers the performance and the bandwidth where this cables is designed to support gigabit Ethernet like I said previously. This will make the cable suitable for handling the data requirement at the university lab, for example, like intensive data tasks. Next, the cables also offer the good reliability and signal integrity, where the shielding in these cables helps to reduce crosstalk and external interference, contributing to better signal integrity. This is crucial in a university lab environment where accurate data transmission is essential for various experiments and research activities. Next, for the router, we are using the same model of router like in the small network. This router have a MU-MIMO technology where the technology allows the router to communicate with multiple devices simultaneously, enhancing overall network efficiency. And other than that, this router also having a beamforming technology where this technology will help direct the Wi-Fi signals toward connected devices, improving signal strength and coverage. This is especially important in a lab environment where a stable and strong Wi-Fi connection is essential for various learning activities. Next, for the modem, we're also using the same model of modem like in the small network. The VDSL and ADSL modem, the integration of a VDSL ADSL modem is convenience for university environments where various types of internet connection may be in use, and it allows for flexibility in connecting to different types of services. Next, although in the router already have the software firewalls, we also added the hardware firewalls for the better security. The hardware firewalls that we are using is Sophos XGS126 with extreme protections hardware firewalls. These firewalls is good to secure the sensitive data in the university labs where the firewalls provides the extreme protection hardware firewalls to uh, to give the better performance for the threat protections. Next, the firewall capabilities. The leverage the firewall's capabilities of the Sophos XGS126 to control and monitor incoming and outgoing network traffic. Implement and customize firewall rules based on the specific needs of the lab environment. Other than that, for the web filtering and content control, Sophos firewalls often comes with web, web filtering features, configure content control policies to restrict access to certain websites or content categories, ensuring a secure and productive online environment. Next, for the switch, we are using TLSG1218MPA Jetstream 16 port gigabit Easy Smart PoE Plus switch with two SFP slots. This switch have a port configuration with 16 gigabit Ethernet ports. The switch allow for the connection of various devices in the university lab, including computers, IP cameras, access points, and other Ethernet-enabled devices. This switch also easy smart features, where it design indicates simplified management features suitable for users who don't require the complexity of a fully managed switch. It may include basic configuration option for VLANs, QoS, and monitoring. The switch also energy efficient, which it can help save power when network traffic is low, contributing to lower energy costs and environmental impact. For the access point, we're using Cisco Aeronet 1815i access point datasheet. And for the server, we are using Dell PowerScale server. This server is offering the scalability where the scalability of power scale is known. It can accommodate a growing amount of data, making it suitable for environment like university labs where data storage needs may increase over time. It is also offer a high performance in storage suitable for demanding application and workflows. It ensures that data access and retrieval are efficient, meeting the performance needs of a university lab network. Other than that, the server also offers the data protection and security. PowerScale typically includes features for data protection and security, including encryption, access control, and snapshots. Protecting sensitive data is crucial in a university lab environment. Other than that, this server also have a backup and recovery, ensure that the PowerScale solution is integrated with a robust backup and recovery strategy. Regular backups are essential for protecting the critical data in a university lab setting. Dah.
Hi everyone, my name is Boon Siling with matrix number 81465. Today, I'm going to present on justification and configurations for small network home environment. The Cat6 cabling was chosen for its double bandwidth compared to Cat5e, ensuring a seamless performance in high data activities. The thicker 24 AWG cable enhances durability and support multiple devices. The Archer Wi-Fi 6 router takes center stage with its advanced Wi-Fi 6 technology, dual band functionality, and gigabit Internet ports, catering to enhanced performance and stability, especially for wire connection. The Archer BR400 AC1200 MU MIMO modem serves as a crucial link supporting VDSL/ADSL, providing flexibility for various internet service providers. The integrations of MU-MIMO technology facilitates simultaneous communications across multiple devices, vital for households with numerous users. Security is a top priority with the Archer BR400 AC1200 modem featuring a built-in SPI software firewall, going beyond traditional packet filtering to examining packet state and content. These advanced security features ensure overall network security and privacy. To eliminate dead zone and provide reliable Wi-Fi coverage, the D-Link 300 megabit per second Wi-Fi booster DAP 1320 was integrated. Its user-friendly design allows for easy setup, making it a famous solution for small home net environments. The overall configuration integrates Cat6 cabling, Wi-Fi 6 router, MU-MIMO modem, SPI firewall, and a repeater, creating a comprehensive and efficient connectivity environment. Emphasis on security with SPI firewall and parental controls, user-friendly component for easy setup, and scalability makes this small home network setup an optimal solution for modern household. Next is medium network, University Lab. Cat6 STP cabling chosen for the lab ensures a stable wire connections with EMI shielding, meeting speed and reliability requirements and supporting future needs. The Archer AX53 routers support Wi-Fi 6, efficiently distributing resources for up to 30 users engaged in data-intensive tasks. The Sophos XGS1206 hardware firewall safeguards research data, offering high-speed connections, Wi-Fi capabilities, and advanced security features. The Archer BR400 modem complements the high-speed router for smooth wireless communication. With MU-MIMO technology, it supports diverse device and activity within the lab, enhancing adaptability and responsiveness. The Archer BR400 modem built-in SPI software firewall protects sensitive data, ensuring security in a medium-sized lab network. The TL SG1218 MPE Z-Stream PoE Plus switch efficiently connect device, supporting IP cameras and access point in a well-organized network. The Dell PowerScale server is recommended for its dependability, providing impressive performance and storage capacity for research and development. The Cisco access point handle high-density wireless environment for up to 30 users engaged in various computer science activities with advanced features like MIMO. The network configuration prioritizes reliability using Cat6, STP cabling, Wi-Fi 6 technology, and security measures. MU-MIMO technology optimize performance, and the server ensures scalability for the lab dynamic requirements. Comparison table. The total cost breakdown for setting up a small home network environment is 10,760 ringgit, while the maintenance total cost is 3,439 ringgit. This includes internet service provider subscription, unified 300 megabit per second, unlimited data, IT on-site and technical support, and backup and restore. For setting up a medium-sized network in a university lab, the grand total cost is 103,124 ringgit and 22 cents, whereas the maintenance cost is 5,659 ringgit. The total cost for the home network hardware, software and potential operation expenses is 14,199 ringgit. For the university lab, it is 108,783 ringgit and 22 cents.
Okay, hello, my name is Muhammad Benan, and I will talk about the challenge. Okay, for the challenge, there are two scenarios, which is home environment and university lab. Okay, for the challenge for the home environment, okay, uh, limited space and Wi-Fi interference. Okay, in home environment, the physical space can be limited, and the presence of wall, furniture, and other obstacles can interfere with the Wi-Fi signal. The interference can lead to poor connectivity in certain areas of the house, resulting in a dead zone where where the Wi-Fi signal is weak or non-existent. Okay, the impact is limited space, and interference can cause connectivity issue, leading to drop connection, slow internet speed, and frustration for the user, who is trying to access the internet or connect the device wirelessly. Okay, then the diverse device also uses standing bandwidth. Okay, with the increasing number of connected device to a home network, such as a smartphone, tablet, laptop, smart TV, and etc., there is a higher demand for the bandwidth. This diversity in device usage can strain the available bandwidth, causing the slowdown in internet speed. Okay, the strain on bandwidth can result in slower internet speed, affecting active affecting activities like video streaming, online gaming, and video conferencing. Okay, this can be particularly challenging where when multiple family members are using the internet simultaneously for different purposes. Okay, for the next challenge for the home environment is ensuring a secure network for work. Okay, with the rise of the remote work, there is a need to ensure a secure and stable network for the work-related activities. This involves implementing security measures such as encryption, strong password, and firewall to protect the sensitive work data from potential threat. Okay. Inadequate security measure can expose work-related information to unauthorized access of or the cyber threat. Okay. The confidentiality or integrity of uh, it can what can I say is it will challenge the confidentiality and integrity of the sensitive data. Okay. For the last point is maintaining parental control for child internet access. Okay. Uh, okay. In the household with children, there is a concern about controlling and monitoring their internet access to ensure age appropriate content and protect them from potential online risks. Parental control feature can help in managing and restricting a child online activity. Without the effective parental control, children may access inappropriate content, engage in excessive screen time, or encounter online threat. With that in mind, establishing and maintaining this control is essential for creating a safe online environment for children. Okay, we move to the challenge for the university lab. Okay, first, it requiring a significant load on the network. University lab often engage in data-intensive tasks such as simulation, data analysis, and collaboration research projects. These activities can generate a significant load on the network as a researcher therefore large dataset to run resource-intensive computation. Okay. Inadequate network capacity may result in slow data transfer, hampering the progress of research project and collaborative effort. Delay in data sharing can impede the efficiency of researcher and affect the overall productivity of the lab. Okay, then maintaining sensitive research data or intellectual property. Okay. Uh, University lab are frequently involved in cutting-edge research and they handle sensitive data and intellectual property. This data may include experimental result, proprietary or algorithm, or confidential information related to ongoing project. Failure to maintain the security of sensitive research data can have several consequences, including potential data breach, unauthorized access, or intellectual property theft. Safeguarding this information is crucial to preserving the integrity of the research and protecting the interests of the university and its research. Okay, for the last challenge for the next challenge for the university lab is turn off wired and wireless network. Okay, the university often first trade-off between using wired or wireless network. Okay, wired connection offer stability and higher bandwidth, but they may limit mobility. In the other hand, wireless connection provide flexibility, but may have lower speed and susceptible to interference. Okay, so with that in mind, choosing the appropriate network infrastructure is critical. Lab with free workstation may benefit the wired connection, while areas require mobility such as a collaborative space may prompt to the wireless connectivity. Okay, stack with striking the right balance ensure both reliability and flexibility within the lab environment. Okay, for the last challenge in use the lab environment is effective control over network traffic. Okay, with multiple user and diverse activity within a university lab, controlling and prioritizing network traffic is essential. Certain application or experiment may require a higher priority to ensure smooth operation. Okay, without effective traffic control mechanism, network congestion can occur, leading to performance issue and delay in critical tasks. Okay, implementing quality of service QoS measure and traffic management strategy help maintain optimal network performance and ensure that important research activity receive the necessary bandwidth. Okay, for the next slide. Hello. Now we move to the to the solution part. Okay. First point. Uh, first point of solution for the challenge that we discussed on the whole environment scenario. Okay, is position router for better coverage. Okay. Proper router placement is crucial to ensure optimal Wi-Fi coverage throughout the home. Router should be centrally located and positioned away from obstacles like wall and large furniture to minimize interference. Okay. By optimizing router placement, you can enhance Wi-Fi signal strength and coverage, reducing the dead zone and improving overall internet connectivity in different areas of the house. Okay, for the next solution is use Wi-Fi extender or mesh system. Okay, Wi-Fi extender or mesh system can be employed to amplify and extend the Wi-Fi signal range. Okay, Wi-Fi extender pick up the existing signal and broadcast it, while the mesh system create an internet of interconnected node for seamless coverage. Okay, this solution help eliminate Wi-Fi dead zone, providing a more consistent and reliable internet connection, especially in larger home where a single router may struggle to cover the entire house effectively. Okay, for the third solution is set a QoS on router for work-related information. Okay, QoS, which is quality of service setting on a router, allow you to prioritize specific type of internet traffic. By configuring QoS, you can ensure the work-related tasks such as video conferencing or file transfer receive a higher priority over the less critical activity. Okay. QoS ensure a smoother and more reliable network experience for work-related application, preventing latency or interrupting during important tasks. Okay. Then, ensure safe online environment for children through parental control function and third-party software. Okay. Parental control feature on router and third-party software can be used to manage and monitor children's online activity. This tool allow you to set the restriction, control access to a website, and monitor usage. Implementing parental control help create a safer online environment for children, protecting them from inappropriate content and potential online threat. Okay. This also allow parents to manage screen time and ensure a healthy balance between online and offline activity. Okay. For the last solution, to whole environment is use VPN for the work-related tasks for extra security. Okay. VPN, which is stand for Virtual Private Network, encrypt internet connection, adding an extra layer of security when working from home. When using a VPN, can help protect sensitive work-related data from potential cyber threat. Okay. VPN enhance the security of data transmit over the internet, ensuring that work-related tasks and communication remain confidential and protect the unauthorized access. Okay, we move to the solution for the USTIL environment. Okay, first, high-speed wire connection. Okay, USTIL lab often involve tasks that require fast and reliable data transfer, such as simulation, data analysis, escalation research. As I said before, okay, gigabit internet switch provide a high swift wired connection for desktop computer and server, ensuring a rapid data exchange between the LAN network. Okay, by implementing gigabit internet switch, the lab can maintain efficient and low latency communication between the device, supporting the high performance computing need to research activity. Okay. For the next solution is enterprise grade Wi-Fi equipment can handle multiple bandwidth user. Okay, enterprise grade Wi-Fi equipment that can handle multiple high bandwidth user. Okay. Uh, as I said before, university lab have a mix of wired and wireless device. So enterprise grade Wi-Fi equipment is designed to handle a large number of simultaneous connection, providing a reliable wireless connectivity for devices like laptop, tablet, and other mobile device. Okay, this solution ensure that researcher and student can access the lab network seamlessly through Wi-Fi, promoting mobility and flexibility without compromising on bandwidth or network performance. Okay, next is advanced security measure like firewall and intrusion detection system. Okay, uh, okay. UCT Lab deal with sensitive research data and intellectual property, implementing advanced security measures such as firewall and intrusion detection system (IDS) help protect against unauthorized access, say like cyber threat or a data breach. Okay, by fortifying the network and with robust security protocol, the lab can safeguard valuable research data, maintain confidentiality, and prevent potential disruption or compromise to ongoing project. Okay, for the last solution for the for the UCT lab is maintenance and update. Okay, network in security lab environment should undergo regular maintenance, including the firmware update, security path, security patch, and system optimization. Okay, this ensure that the network infrastructure remain up to date and resilient against emerging security threats. Okay, with that in mind, regular maintenance minimize the vulnerabilities and enhance the network stability and also provide overall performance, good overall performance. Okay, it also ensure that the lab remain in compliance with the latest security standard and regulation. So it reducing the risk of security accidents. Okay, let's move to the next slide. Okay, now we add the summary part. Okay, for the summary, both offer insight into the network structure planning, but complex planning is challenging due to numerous equipment combination. Okay, small network like environment are easy to configure due to their smaller number of user and the area of connectivity. In other hand, on the other hand, on the other hand, the network require additional equipment like switch and access point for more user. Both scenario require stable first and second connection, but the computer lab need to ensure that it can handle heavy load while a small network are not designed for many users. Okay, the two network design are compared based on their coverage area, equipment needed, and cost planning. A small network area can cover 50 until 100, while a medium network cover 100 meter. Okay. The smaller network can use an ISP provided modem and a router, while the medium network require industry graded equipment. The home network is more cost effective, providing a high-speed internet access to limited number of users. However, it's fall behind the scalability due to the choice of router and access point, while allow more devices to connect. Okay, now we move to the recommendation part. Okay, to plan a network effectively, it is crucial to define objective clearly. We must understand the user requirement and plan with scalability in mind. This involves understanding the network intended users such as daily home use, or high bandwidth for utility lab. The appropriate equipment should be chosen to support this activity. Additionally, the network should be scalable, allowing for the future upgrade or change. This means that the network bandwidth can be upgraded to support larger user or faster data transmission, and the available router and modem should be support this. Okay, with that in mind, choosing equipment that can support 4 until 5 years of technological update is essential for successful network plan. Okay, to the next slide. Okay, now we at the end of the presentation. For the conclusion part. Okay, in conclusion, the team learned about the network structure, planning for various scenario and location, selecting the best network topology and equipment, and overcoming the challenge and choosing the topology for a utility lab. Okay, they also learned importance of functioning team for successful completion, which was achieved through the discussion, through online discussion and occasionally meeting at Petare. The team experience highlight the complexity of network design. Okay, that's all from us. Thank you.